Good day, everybody. This is Panama Bartholomew with the Building Decarbonization Coalition, and welcome to Building Decarbonization Coalition Presents, our monthly, sometimes more often than monthly webinar series where we bring you some of the brightest lights, stars, doers, thinkers, and policymakers of the building decarbonization world. We're so excited. We got a great one today. Jane Melia from Harvest Thermal is joining us today. They have an amazing product line, and they're here to talk to us about what Harvest Thermal is doing, what they're seeing out there in the marketplace, and then really engaging with you all in a conversation about the state of the market and where their product can play in that. So thank you so much for joining us. I'm just going to give a little bit of background on this webinar series and the BDC, and then we'll hand it over to Jane. So Lawrence, if you wouldn't mind, next slide, please. So you are joining a call with the Building Decarbonization Coalition, known by friends and family as BDC. We are a coalition of utilities, manufacturers of heating equipment, the design and construction community, government agencies, and nonprofits. And we work together to eliminate pollution from the built environment. We do that through both policy activities as well as market activities. And we believe that electrification is going to be the fastest and most cost-effective way to eliminate pollution from buildings. Next slide, please. Back in 2019, oh so long ago now, it feels like a generation more than just 3 years, we released a roadmap to decarbonize California's buildings. And in that, we really laid out our vision for what we think needs to be accomplished to be eliminating pollution from buildings. If you could advance it, please, Lawrence. In there, we set a number of numerical goals for the elimination of emissions from buildings. And those included starting to set building codes for products so that we no longer allow emissions adding appliances to be installed in new construction. And that the state of California should set a date. We recommended 2030 for when the state should start phasing out the sale of gas appliances. And we set this based on the state's goal to get to carbon neutrality by 2045, and recognizing that your average water heater, space heater has a life of about 15 years, give or take. And so if you're going to be installing any gas equipment after 2030, it's going to be hard to meet that 2045 goal. Next slide, please. In order to get that done, we laid out 5 different major overarching market goals, market and policy goals that we think need to be achieved before you can bring about this major transition off of gas appliances in buildings. 1, we need to dramatically scale up awareness of the benefits of building electrification across all stakeholder groups. 2, we have to make sure that electrification is a good customer experience, particularly on the financial side, that customers from a capital perspective as well as an operating perspective are getting a good value proposition out of building electrification. 3, we actually need to build sustainable markets for businesses to be able to make money off of electrification. And this is a transition market. And so we're transitioning very likely, mostly people that are already working in gas over to electricity. And we need to make sure that people are able to make money, and preferably more money, doing electrification than putting in gas appliances. 4, we need to make sure that we have a supply chain that can meet the demand that we're going to be creating. Climate change forces us into a situation where if we're going to meet our goals, we're going to have to be renovating and retrofitting gas appliances at a faster rate than the natural turnover that we would normally have with appliances. And so how do we work with the supply chain to make sure that they are ready and that we're getting barriers to the supply chain out of the way, such as undersized electrical panels and permitting delays. And number 5, we need to align our policies. We're not going to be able to achieve our goals if our building code policies, our energy efficiency policies, our affordable housing policies, and so many other policies are out of alignment with our climate policies. It makes no sense for us to be investing billions of dollars into building decarbonization when we're also investing billions of dollars into affordable housing projects that are still allowed to put natural gas in them. It makes no sense. And so we need to align our policies. Next slide, please, Lawrence. And so this webinar series is one of our attempts to meet our first goal. It's around awareness, and it's working with those parts of the building decarbonization community to bring to you who we see as some of the leading lights out there doing some of the best work, to come and present on their work and then engage in a conversation with you and hopefully build relationships through this effort. And so we really want to thank Jane and Harvest Thermal, and we want to thank all of you for joining us today. Next slide, please. We have some more events coming up. We've started a New York policy call every second Tuesday. For those of you that are into the Empire State, we have a call at 1 p.m. Eastern where we go over everything happening in a policy in New York. And so you can go to our BDC upcoming events website to register for that. And then we have a really exciting March event coming up for BDC Presents. So we're just about to announce. So bookmark upcoming events on BDC's website to follow along for other wonderful events like today. Next slide, please. So just a couple logistics. Everyone is muted. We had just under 200 organizations register for this event. And so we can't just have a free for all. So everyone's muted, but it is Zoom. So, be responsible. Please ask your questions via chat. We may ask some speakers to speak to your questions at the end of the remarks if you get too deep into COP questions. The webinar is being recorded, and members of the webinar can access the recording on our website and our member portal after that. That's one of many great benefits of being a member of the BDC. So many other wonderful benefits. We have a private lunch and learn series where it's more of an informal opportunity to get together with some of these leading lights and have conversations. We have a fantastic newsletter that gives a rundown of everything happening in building decarbonization each month, and so many other benefits. So if you go to the BDC's website, buildingdecarb.org, you can see those member benefits, and please do join us. Next slide, please. So with that, Jane Melia from Harvest Thermal, she comes to us from a bunch of different work in clean energy. She is the CEO and founder of Harvest Thermal. You're going to hear all about Harvest, but they use machine learning, smart IoT, and HVAC technology to basically offer everything you need for electrification. I'm trying to talk her into finding a way to have us be able to cook on top of their equipment, but we're still working on that piece. She has held a number of leadership roles at different technology startups, working in solar, working in storage, working in quantum tech, which I don't understand. She's a civil engineer by training, but she can also talk to people. And she has a PhD in fluid mechanics from Cambridge University. She's loved clean energy as long as she can remember. So please, everybody, a warm Building Decarbonization Coalition community welcome to Jane Melia from Harvest Thermal. Thank you for joining us, Jane. Over to you.
Well, thank you very much, Panama. Hello, everybody. It's a real pleasure to be here, and thanks for a fun introduction. So let me start by sharing my screen. See if we can get the technology to work. How's that going?
Looks great.
Okay. All right. So we started Harvest Thermal because my co-founders and I saw that home heating and hot water were a huge problem for the climate, and that there weren't really cost-effective solutions out there to enable the mass adoption that we need. How can we electrify homes and help them transition from gas in a way that's cost-effective and comfortable and do it at scale? And how can we do that while supporting a strong, resilient grid and maximize the use of low-cost renewable electricity to really slash those emissions and save on bills? So we first started working on our system back in 2017, and we realized that with just one heat pump, a humble tank, and some really sophisticated controls, we could solve this at scale and have a huge impact. So our systems have shown in the field that they reduce bills for heating hot water compared to gas by between 30 and 50%, that they also cut emissions compared to gas by 90%. And they do that while capturing electricity when it's cleanest and cheapest, like an upside down duck curve, avoiding peak times and capturing, and supporting a strong, robust, clean electricity grid. So we believe they offer a real path through the challenges of electrification to comfortably transition our buildings to a lower carbon model. So here's a quick snapshot of what Harvest does, and I'm going to describe it in a bit more depth later on. But to summarize, a Harvest thermal system uses just one heat pump to deliver both heating and hot water to homes, operates a hot water tank as a thermal battery, completely decoupling heat pump operation from the delivery of hot water and heating using the cleanest, cheapest electricity. This is all enabled by the brains of the system, the Harvest Pod, which is a smart, connected IoT controller, which orchestrates all the devices to the highest and most cost-effective performance. But before I dig into the details, I want to take a step back. So many of you in the audience are probably aware that buildings are responsible for a very significant part of carbon emissions, roughly a third overall. Now that building energy use covers a lot of things, from lighting, computer use, dryers, dishwashers, heating, hot water, but it's pretty clear that the vast majority of how we use our energy in homes is due to heating and hot water. That's about 2/3 of overall residential energy use. Mostly that is from burning gas for heating and hot water. And if we can tackle that problem, we'll have the single biggest impact on the impact of our homes on the climate. And so it's really important that we figure out a way to do that cost effectively and at scale. It's worth noting that when we think about gas in buildings, and that's been the focus of a lot of discussion, a lot of great policy measures recently, the vast majority of what we're talking about is really heating and hot water again, around 90% in California, for example. So again, if we can figure out a way to comfortably and cost effectively swap out the gas heating and hot water in our buildings, we're going to really help have a huge impact. Now, heat pumps are the true heroes of this story. Their ability to move heat rather than generating it means that they deliver far more heat into the home than they consume, delivering rated efficiencies of well over 100%, as high as 500% in some cases. They sip electricity gently while delivering reliable heat to the home. So they can be ground sourced, water sourced, or just simply and most commonly air sourced. They really knock it out of the park in terms of efficiency. And that's the most powerful and amazing tool we have to decarbonize buildings. But there are barriers to scaling heat pump adoption. First of all, there's the issue of costs. How can we deliver compelling cost reductions compared to gas to enable that mass adoption? How can we transition to electricity while reducing people's energy bills? And how can we electrify without requiring 2 heat pumps, one for space conditioning and one for hot water? And can we do it without triggering the need for panel upgrade or for refrigerant lines in the home? Then there's the issue of the timing of energy use. Can we deliver heat electrically without aggravating the duct curve and increasing grid costs? Heating in particular is very time driven, with most heating needs in the morning and to a lesser extent in the evening. If you put that on top of the duct curve of costs and emissions, heat pumps that operate without storage tend to increase demand just when electricity is more expensive to produce, increasing the peak loads, particularly mornings in winter. And it's not able to take advantage as much as we would like from that low cost, clean midday electricity. And finally, how can we electrify homes without increasing the emissions of refrigerants that have high climate impacts? Now, let's go back to the Harvest system and discuss how we have tried to tackle these challenges. So the Harvest Thermal Pod is an IoT system controller. It's about the size of a large shoebox. It fits on the wall of a garage, mechanical room. It's also sized to fit inside a tank closet. It integrates our control unit and software, physical controls, pumps, sensors, flow meters to accurately orchestrate the operation of the whole system. It operates that heat pump when electricity is cleanest, cheapest, and most abundant, saving on energy bills for the homeowner and on carbon emissions for all of us. It also operates that heat pump most efficiently, for example, in the middle of the day when it's warm and heat pumps are more efficient. That heat pump delivers water at high temperatures to a storage tank, and we operate this tank as a thermal battery, constantly managing its state of charge with a high level of precision and visibility to completely decouple the heat pump operation from heating delivery. This delivers both heating and hot water to the home whenever it's needed, using continuously variable capacity for maximum comfort. Now here you can see it's illustrated with forced air, but it also works with radiant floors. Now, we sometimes refer to Tesla cars as computers on wheels, and you can kind of think about, and we're not the scale, of course, of Tesla, but you can kind of think about this as a computer on a tank. The system is very smart, it's integrated, it's cloud connected for over-the-air upgrades, with machine learning to optimize that heating delivery to the homeowner's needs. Now, let's see how that helps tackle the challenge we described earlier. Well, here's a chart showing the average daily emissions for a grid with significant renewables. It has the shape of the classic duck curve with higher emissions and production costs in the mornings and evenings, and lower emissions, lower marginal electricity production in the middle of the day when solar electricity is most plentiful. Now, the challenge that we saw earlier when heat pumps are moving in to replace gas, which they need to do, was that when they operate instantaneously to heat the home, they aren't really able to benefit from the duck curve. They're not reducing emissions as much as they could, and they're increasing peak loads on the grid, which in many places will increasingly occur on winter mornings. Now, wouldn't it be great if we could somehow operate with an inverse duck curve? Well, that's exactly what the Harvest system does. With the vast majority of the electricity that we use shifted to the middle of the day, we basically shift electric load from peak to off-peak, and not just for hot water, but for the whole heating and hot water load, the inverse duck curve. And that means that we always capture the cleanest, cheapest electricity, reducing user costs, supporting an affordable, clean energy grid. So what does that deliver from a practical perspective? Well, here is some data from the operation of our Harvest homes, ranging up to from 1,300 up to 3,100 square feet, from 2 to 6 people. Our systems have delivered carbon reductions compared to gas by over 90% and by about 50% compared to standard heat pumps, enabled both by super high efficiency and by load shifting. And what about affordability? Well, we've substantially lowered energy costs. And I believe we're the only system on the market that delivers really a compelling value proposition in terms of cost compared to gas. The Harvest system is also streamlined. One heat pump to deliver heating and hot water, a standard tank, and standard distribution via forced air or radiant floors, plus of course the Harvest pod. The heat pump we use requires only 15 amps. None of the homes we've deployed in or are currently planning to deploy in have had to do a costly panel upgrade. And that you typically need when you're deploying 2 heat pumps for your HVAC and your hot water. And we have no refrigerant lines in the home. And of course, we've designed the pod to be as compact as possible. We want this to work not just for big homes, but for small homes as well. It fits above the tank, inside a tank closet. So concretely, here's some data on the energy bill reductions to these homeowners achieved when on time of use rates. It's by about minus 30 to 40% compared to gas and about minus 15 to 31% compared to regular heat pumps. This is achieved by a combination of really high efficiency operation as well as that load shifting, delivering a positive payback even without incentives. Most importantly, it delivers super stable temperatures and lots of quiet, comfort, and very happy customers. And of course, reliable heating and hot water. Finally, for the question of refrigerants, we use the Sanko 2 heat pumps with CO2 as a refrigerant. It has a global warming potential of 1. Most heat pumps being deployed have a global warming potential of over 2,000. So you can see the difference there. Now, some of you may be wondering a bit about the how behind this. So I'm going to geek out a bit for the next 3 slides. Please bear with me. So first of all, you may be asking, how can we use a 1.25 ton heat pump to deliver the heating and hot water load of a 6-person, 3,100 square foot home? Well, this is enabled by using a thermal battery whose storage capacity is equivalent roughly to that of a Tesla Powerwall to buffer the heat pump, and by the precise operation of the state of charge of that battery. This chart shows the heating load of a home on the coldest day in winter in the Bay Area, a mid-sized home in San Mateo County. And this has a huge peak in the morning, 3 tons in this case. But the average load over that day for heating plus hot water averages less than 1 ton. So you can size your heat pump to deliver that average load as long as you can manage your tank accurately enough to store that hot water and deliver it when needed. So the tank is sized for the peak hour, the heat pump for the peak day. Also, by storing the water at high temperatures, in this case 150 Fahrenheit, we're able to stick to manageable tank sizes. For the homes we're currently deploying in San Mateo County, these are all 119-gallon tanks. Second, I've mentioned several times about efficient operation, and I just wanted to explain a little bit about how we're achieving that. And there are many things we're doing on this front, but one example is that efficiency of heat pump varies quite significantly with outdoor temperature. It peaks when it's quite warm outside. And here you can see how it varies with outdoor temperature for the heat pump that we're using. Now, because we can decouple the timing of operation of the heat pump from heating delivery, we can choose to operate the heat pump not at say 32 degrees in the coldest hour of the mornings, but more toward the middle of the day when even in winter we might hit 45, 50 degrees. And this is what we do to really enable to enhance the efficiency. That's one example of how we build a high efficient system. Now, there are many other things going on in the system for optimized performance, really a lot of different elements we're focusing on. But the net is it gives us very high field measured efficiency compared to most systems. From soup to nuts, from that heat pump operation, including thermal losses, the operation of our pumps, fans, controls, and everything, we have a field measured performance efficiency over 6 months, including winter and the early summer, of about 3.1. This is among the highest seasonally adjusted COPs for high performance variable capacity heat pumps, without taking into account the fact that many of those are measured in the lab. So I just want to close with two last points. First of all, we're at a really important moment in the decarbonization movement, with strong tailwinds of awareness, emerging incentives, regulations across the US and around the world, and of course, new technologies to meet different needs. So I want to shout out to everybody in the audience who's really helped make this happen. Building tailwinds that together will allow us to really make the change we need. In fact, 54 cities in the UK, I believe about a year ago, we were about 34, is that right? Finally, here are some photos of our systems in place and being deployed. So I'm very pleased to announce today that we are launching commercially this week, with our first commercial installations underway right now as we speak. This is a progressive rollout focused on the California Bay Area, and we're always pleased to add homeowners in these locations to our waitlist, expand our pool of trained contractors, and grow our team. And I wanted to shout out here to Air Care and DG, who are currently have trained all their contractors and they're currently deploying our systems, as well as some of our strong partners. And there are many, but a quick shout out to Franklin Energy, AEA, with whom we're deploying projects in the Bay Area, Eco2 Systems, which are delivering, of course, those super amazing heat pumps that we're able to benefit from. And of course, Peninsula Clean Energy, who is sponsoring some of our projects. Finally, we're super excited with the support of everybody who's contributing to the piece of this puzzle to be able to deliver on affordable, scalable, and super low carbon home comfort. Thank you for your attention.
Jane, so good. Are you sure you have an engineering degree? Because you are an excellent communicator. Apologies to all the engineers in the crowd. Seriously, wonderful presentation, amazing technology. It's a good thing you saved a lot of time for questions, because there's a lot of questions. And so I'm going to go through a bunch of them. I may ask some folks to ask them themselves, but there's a lot of questions about cold weather in here, and cold weather applications of Harvest Thermal, your unit. So can you talk about your plans for cold weather work, how it would affect the efficiency? Would you need larger tanks perhaps in, say, New England? But what are your thoughts around the application and future applications of Harvest Thermal in the area you're not rolling out in right now?
Yeah, absolutely. So cold climates, of course, really important. And the good news is that we already have some benefits in that we can choose when to operate the heat pump. So rather than having to operate at 5 a.m., we can operate the heat pump towards the middle of the day, which gives us often a significant boost in temperature compared to other heat pump operations. Clearly, another thing is that we are currently working with one particular heat pump. We can double those heat pumps. We can work with different heat pumps. The pod is designed to be as flexible as possible, and we will grow and integrate different heat pumps and high capacity heat pumps as they enter the market. But whoever asked the question is quite right. It's a question of balancing what is the peak daily load that we need to meet, and you look at what is the peak load for the location you're looking at and make sure that your heat pump can deliver that. And then what is that peak boosted hourly load that you're going to need to meet? And that's driven by the size of the tank. We're storing temperatures currently at 150 degrees. We can boost that to 170 degrees, which increases the energy density, which will add somewhat some ability. But in some cases, we may need to install a larger tank, or we may need to install a second smaller tank. One thing that we are exploring, we'll continue to explore over time, is for certain locations, let's consider looking at phase change materials and other ways to really meet the need. And then, of course, there is that backup that nobody really wants, but really if it allows you to deliver that heat on the coldest day and still deploy the system the rest of the year, maybe you have a resistance boost for just a few hours, a few days of the year. It allows you to benefit from the rest of the system the rest of the time.
Wonderful, thank you. Can the harvest thermal units also provide cooling?
That's a great question. So the current system that we're commercializing are heating and hot water only. We really focus on that system first because A, we're trying to get gas out of homes, and B, we want to get a product to market as quickly as possible. We want people to be able to have a choice not to deploy their gas furnaces in the market, and we want to limit the numbers that are going in every day. So rather than waiting, we came to market with a heating and hot water solution. But we actually have had our first system in place with cooling since September. We're currently running that through the tests. We will be running some commercial pilots in the coming months, and we expect to bring that to market later this year. It's a progressive approach, starting by just having a bolt-on AC unit that integrates with the same system, and we're going to be expanding on that capacity over time. We want to make sure that people are able to move away from gas without sacrificing their comfort, and in some cases safety, for having cooling. I want to flag, though, that every system going in place today has the option of night cooling. You can bring in clean, cooler air at night if it's colder at night than it is during the day. So it acts like an automatic whole house fan, but with filtered air drawn into the house nice and quietly. And another feature that I didn't mention is just we have recirculation mode. So with the MERV 13 filters, you can filter your air for our Bay Area smoke season every September, and make sure that your air indoors stays nice and green and not the horrible orange that we want to avoid.
Indeed. Now, this question is asked a few times in the chat, and of course, it's the same question you always get, just like how about cost, and there's no way to predict cost. Every house is different, of course, and every project is different. But in general, when you're looking, you made some claims there around economics, and so just wondering, all things considered, ROI and payback for a retrofit application without time of use rates.
Yeah. So the economics are based on a couple of things. So first of all, there is the overall efficiency of the system. The system is highly efficient. So even without load shifting and time of use rates, we're going to consume less electricity than most competing alternatives. So that is going to reduce bills. However, the reality is that time of use rates are really important to allow us to align behaviors with the needs of the grid as we seek to introduce more clean electricity into the grid, right? And that's good for all of us. It reduces emissions and NOx and all those things that we need to get out of our air. And that is very in line with what we're doing here. We're actually allowing that inverse duct curve to really capture that cleanest, cheapest electricity. So those numbers that I showed of the 40-odd% reduction compared to gas, that is based on assuming both the efficiency gains and the time of use rates. And by the way, those are not theoretical calculations, those are measured in the field. So that's one thing. So we have that. And what that does is typically, most heat pump installations, they can kind of break even in terms of bills compared to gas, but it's hard to actually reduce those costs. And, it's actually relatively cheap to install gas heating and hot water systems, particularly if they're not permitted today. So that makes it a challenge for electric systems to overcome that kind of barrier to entry. By having a bill reduction, you have a crossover point, you have a payback. That allows you to have financing options, all those things. That is going to deliver a payback, just as we did with solar in the early days. You get that payback as long as you can figure out that financing option, even without incentives. Now, in terms of the more precisely to the homeowners question, so we are deploying systems in the California Bay Area, heating and hot water systems, complete retrofit into those homes, in some cases requiring duct upgrades. they're coming in at $25,000. Specific homes, of course, it varies very much on the home, without any incentives. And of course, our systems are eligible for incentives.
Yep. And I'd say $25,000 is about what we're seeing for your average Bay Area, Northern California, single family home for a heat pump installation and a heat pump water heater installation. We're seeing it about the same as that. So that's interesting. You talked about incentives, Jane. Incentives are already, I'll say complicated. But for a system like yours that uses one heat pump but provides two great end uses, how in your conversations with the administrators of some of these rebate programs, how are they looking at your system? Are they looking at it and say like, oh, this is one heat pump and therefore one rebate? Or are you able to make the case that really we should be focusing on end uses rather than how many heat pumps?
So we have received approval that we're eligible for both the HVAC and the heat pump water heater tech incentives.
Fantastic. Well done. So I'm going to ask a question about the Harvest Pod now. And if you could go into great detail and lay out everything about it for your competitors on the line, that would be great. Kidding. Could you talk about the energy use of the Harvest Pod? We had a question in here about how much more energy does charging and discharging a Harvest Pod require compared to simply running a regular heat pump?
Well, we're using a circulated pump, which uses a few watts. We're controlling the fan of the air handler, which is a few watts. So really the actual consumption of the control devices are very low indeed. One thing that is important to consider are the thermal losses. And we actually operate our system taking thermal losses into account. And that what you want to do is make sure you don't store hot water for days on end. You want to cycle it or store it up just for the amount you need for the next 12 or 24 hours, so that you're going to sit there for the least time possible and avoid just that linear thermal loss that's going to happen over time. We also are very, very careful about insulation. It's really part of our training program. It's cheap, it's straightforward, it's low tech. Wrap the tank, wrap the pipes. And what we found is that the thermal losses of our systems in place operating is less than 10%. Somewhere between 3 and 7 or 8% is what we've measured in the field. And that is typically less than you'd see through cycling with an electrochemical battery. So overall, the net, when I showed those efficiency charts, that incorporated all that into the equation.
Great, thank you. A number of people were very excited and cheering up at home when you talked about the 15 amp service required for this. And there were some questions about, is there a square footage limit in being able to rely upon those 15 amps for the service? So say if you had a much bigger home, would you need to upgrade that circuit to something higher than 15 amps?
Well, so I hope I'm answering the question properly. So for me, we're sizing the system based on the peak daily load. We're sizing the heat pump based on the peak daily load of the year. And we work with our customers to understand what is that peak daily load. And some of our customers, it might be worthwhile them spending a little bit of money on a little bit of efficiency upgrade to make sure they can get that down to a manageable amount. Some of them have got bigger challenges. In some cases, you really need to work on your efficiency first. But really, it's a look at what is the energy needed for this home on the coldest day of the year, and can that be met by one Sanko 2 heat pump? And that is the driver, really. Now, some homes, in fact, we're working with one customer who actually had 2 separate heating systems, 2 gas furnaces, 2 gas tanks. Pretty large home and big home, and they're quite happy to be deploying for those 2 zones. To Harvest systems, very equivalent. But it really is it's all down to the math of what is the load needed, and will one heat pump meet that load? And if not, what are the steps that need to be taken to enable that?
Thank you. A question about some jerry rigging. Can the Harvest Pod be added to existing systems that say already have a Sanko heat pump water heater?
So that's an it depends question. That is, let's take a look. It might require some plumbing. Obviously, will require some plumbing. How hard depends on where things are and so on and so forth. But very happy to take a look.
Fantastic. That's a great engineer answer. Yeah, it depends.
Sorry, I just would say we do have some people who are working on that, who have deployed heat pumps. They did it, but they put their heat pump water heat in with harvest in mind, but no reason why not.
Yep. A question about the COP curve that you put up there showing the effect of temperature on efficiency of the systems. Was that a COP curve for just the harvest system for the Senko units, or was that typical one for all heat pumps?
Yeah, so that was a Senko 2 curve. It came straight out of their manual. Prettied up for the presentation. For heat pumps, they'll tend to be a similar curve, but I don't have the exact ones in mind, but they typically do prefer to operate when it's warmer. So if you can shift it, and sometimes shifting from having to operate at 5 a.m. to being able to operate at noon can actually have a significant temperature difference in the ambient temperature for the operation of the pump.
Thank you. People want to know about expansion plans. When are you going to be coming to the rest of America, but particularly Monterey, California? When do you expand beyond the Bay Area, and what are you looking at some prime geographies to expand?
I mean, as soon as possible. As soon as possible. Now, obviously, we want to do everything, right? We want to help get gas out of homes, and we want to do it quickly. We want to limit the number of gas furnaces and gas pumps that are gas hot water heaters are going into homes and are going to stay there for a long time. My experience working in startups is that you got to play the long game. If you go try and do too many things too fast at the beginning, you end up falling over. So we're going to do very solid deployments in the Bay Area. That can extend a little bit further. We're going up to the North Bay and so on. So Monterey is not too far off the map. We are in discussions with companies on the East Coast. We are planning what our next steps will be over there. The whole of the West Coast is also a great market for us, Oregon, Washington State. So it's not going to happen within the next, I'd say 6 months, but after that, watch this space.
Fantastic. And you see Jane's contact information down below, and let's start the list. Let's start the waiting list. You're going to have to, do the Tesla waiting list and be charging people a couple $100 to get on the list there, Jane. So in your diagrams that you used to show the unit, you were showing ductless systems, but in a previous answer to a question, you mentioned ducted systems. Are you able to do both ducted and ductless?
So all our systems, we are delivering a central system. So typically we are using the duct work for existing homes. So it's a central system, it can be a new home, an existing home, and we use central duct systems, or we can also work with radiant floors. So both are possible. Okay. So it is a ducted system.
A question about air source versus ground or water source. Mm-hmm. Obviously the Senko 2 is an air source heat pump. Yeah. Have you thought about, explored the possibility of working with ground source or water source heat pumps?
So, I mean, what really matters to us is, do we have a high performance heat pump that is going to perform well and it's going to be cost effective to the homeowner? And there are some instances when those alternatives are going to be maybe the appropriate ones, particularly in extremely cold climates. Ground source gives you that stability of the anchor, that is in the ground. But and that's a good trade-off in coldest locations, but it comes at a pretty high installation cost. So in most cases, the air source heat pump, which is increasingly good at low temperatures, meets many markets. For example, the Senko 2 actually delivers the same capacity, the same heating output down to 4 degrees Fahrenheit. So its efficiency is lower, but we can also play on that temperature chart to try and maximize that more so than other deployments can, because we decoupled heat pump operation from the time of delivery. But it also does deliver heat right down to pretty cold temperatures. It gives us a lot of fair amount of leeway. So yeah, I mean, open to other sources of heat pump, but we want to make sure it meets that bar of affordability And apart from cold climates, I think air source is a really good way to go.
Thank you for that. I'm sure that will engender some further discussion in the chat. Question about storage tanks.
Yeah.
And that's going to be, I think a big conversation in the building decarbonization space coming up. But how has your exploration of different storage tank sizes gone? And in particular, different form factors that can allow for fitting it in perhaps untraditional places such as crawl spaces, attics, small closets, under counters. Have you been exploring the opportunities to work with different size tanks?
We have, and certainly that's something that we're considering and looking at ways to optimize things. Now, one thing that's I think quite important with the use of the Sanko 2 in particular is that it generates water at high temperatures, so 150 Fahrenheit or higher, whereas most heat pumps are generating water at say 120 Fahrenheit. That means we have actually quite significantly higher energy density in our tank. You want to deliver that water 120 to the home. So the capacity you have in the tank at 120, that's it. Whereas we have 150 degrees in the tank, gives us a lot more energy capacity above what we need. So much more energy is stored there. So this is why, for all the homes we're about to deploy in San Mateo County, these are mid-sized homes, up to about 2,000 square feet. We're putting in one 119-gallon tank. That actually fits into a standard tank closet. So because of that, we're able to capture standard, affordable tanks that fit into tank closets using standard plumbing connectors, and that really meets the need. Now, are there other situations? Yeah, we've been actually, in discussion about some homes where they may need to put it in a crawl space, and that can work fine. We can also use smaller tanks that are coupled together. When you start coupling things together, you start increasing surface area, you start increasing connections. And so you've got to also be wary about what you're losing and so on. So there are many different ways, and every home is unique, and we'll always work with the homeowner to figure what is the best place for them to put the tank and what's the right tank configuration for them.
Thank you. A lot of questions about cooling. So I think you have big cooling demand opportunity there.
Right.
Another question about those standard tanks. What are you thinking, back to the jerry rigging again, about would you be able to put in a unit and be able to rely upon the existing tank until it dies, and your comfort level with doing that? So you put in the Sanko 2 unit connected to the existing gas water heater that they have, or heat pump water heater, I guess, potentially, and then hooking that to your harvest pod and to your ducts or ductless system. I'm designing on the fly here, Jane. But your comfort level, yes, your comfort level or thoughts around using existing tanks versus bringing in a new one.
So there are good tanks and bad tanks, right? I mean, obviously it's a tank, but once you start going into detail, it's like lots of things. Some tanks are better than others. How many ports do they have? Can you minimize cross flows and loss of efficiency? How is the water being injected to the tank? Is it going to create vertical momentum and hence reduce the stratification and the efficiency? So there are good tanks, there are bad tanks. We recommend that people go with the Sandem tank, which belongs with one of those good tanks, and we also open to considering others. Now, there are also cases where in existing homes we've been able to reuse an existing tank. The truth is that in my home, I have a Sanko 2 tank, and I had a perfectly good gas water heater tank, just like I think the person who posed this question had, and I just hooked it on a series, which gives me like the capacity of a bigger tank. And it was very easy, and I didn't have to spend any money on it, and it just gave us a little bit more capacity. So it's certainly doable. You just want to make sure that you're not causing more losses than it's worth. And so it needs to be thoughtful. You need to look at that tank.
Right. A number of people have questions about where they can get more information and just how much information you put on your website. Can you talk about what is and what is not on the website, and what they'd have to get more through talking to some of your colleagues?
So we we're constantly trying to expand the website. It's like that problem with when you're a startup company trying to save the world, it's actually hard to spend time on the website, but we need to. So we're trying to get to that, and we're adding more customer pages. We're adding more pages for the contractors. So please bear with us. We'll get it in place as soon as possible. So we have some material on the website. We're going to be adding more. We also have a contact us page on the website. We also have, very soon, we'll have the ability for people to sign up to get on a wait list, figure out how to get their home size in terms of suitability for the system. Also checking the zip code. Is this an area we can focus on right now? So all that is coming, is in the works, and should be in place very soon.
Great. And if contractors that are on the call want to find more technical information, they should probably reach out to you to talk about potential.
Yeah, absolutely. So we are currently actually running training for contractors. We have a training actually happening next Tuesday, and we keep having them regularly. The system is simple. It's heat pump, it's tank, it's not rocket science, but there's some things we want to make sure people are aware of. How you insulate it, and the best and most effective order of installation, and make sure we answer their questions. So please reach out to me, or I should have put my colleague Michelle's name on there, but reach out to me and I'll forward them to the right person to get you signed up or answer your questions.
Wonderful, thank you. A question about if the home has solar and the economics of using the pod and the water tank as a thermal battery relative to the cost of deploying a power wall, and any capacity comparisons.
So I can hear two questions in that. So one is the solar, I'm assuming that's solar PV, solar photovoltaic. So, the harvest system is kind of always using electricity in the middle of the day when it's cleanest. So it can be from your roof. It can be from the grid, which is also solar. I also have PV on my roof, and that's great. And we're able to take advantage of that. And so there's no particular conflict there. The way I think about it is, Tesla Powerwalls are absolutely fabulous, and electrochemical batteries in general are really fabulous for your electric load. Thermal batteries are more cost effective and better for that thermal load. So I think there's actually a need for both. Specifically, if you want to run a heat pump from an electrochemical battery and meet that peak hourly load, which you're going to have to do because you're effectively running that heat pump instantaneously. You have the battery, then the heat pump, then the home. So you have to be able to meet a quite sizable peak load for that heat pump. You're talking of pretty much a dedicated Tesla Powerwall to that heat pump operation. So it's not kind of, I can use my existing Tesla Powerwall to also do my heating. It's no, you want to add a battery. What that means then is that you're adding additional material, additional equipment. Right? So the harvest system using the heat pump and the tank you need anyway, and you've got your thermal storage, you've got your storage. If you want to use a battery, you're going to have the heat pump, the tank, and the Tesla Powerwall. So you're inherently increasing the cost to gain a similar load shifting. So inherently, you always have more equipment for it, so it's always going to be more expensive. I hope that makes sense. It might be a little confusing.
Nope.
I was waving my hands a bit.
A question about multifamily apartments.
Yeah.
And thoughts around multifamily apartment design and the applicability of your systems, how you would go about doing that. And then somebody said they might have heard about you guys doing a pilot with a multifamily development, and wondering if so, how that's going. Yeah, so we're really focused on, we could do many things, right? There's always many things, so many problems to solve, and and I think there's a place for each of us to contribute to all these solutions. So what we're focused on right now are homes with an individual heating hot water system. Now that could be a single family home, it can be a duplex, it can be a multifamily home. In fact, we're currently in the planning process for a low income multifamily home project in the Berkeley area with 4 units per home. And we're really excited about this because our mission is really about, not just clean energy, but let's help make this affordable, and being able to do it in low income homes is really excited to be able to do that. So, but these are for apartments in each building that each have their individual heating and hot water. So that's really where the limit lies today. Now, in the future, will we expand that? Perhaps, although at the moment we have our work cut out just tackling this market. Great, thank you. A question about contractors and the
Yeah.
state of installation around HVAC and water heating in America right now, or you can keep it to the Bay Area. How are you choosing your contractors that you work with? And obviously, the effectiveness of your product is going to really be heavily based on the quality of the installation. And so could you talk a little bit about what you're thinking about the quality of installation in the HVAC and water heating communities right now, and how you go about selecting your partners to work with, and how you do any QC, QA work with them?
Yeah, absolutely. I mean, the contractors, they're such important partners, and they are, we work hand in hand to make sure that the customers get the best experience and the best comfort with the system. And that's why we put in place a strong training program, and we're rolling that out. And we're working very closely with those contractors, particularly in their first deployments, to make sure everything is clear. They've got checklists, they've got information, they've got videos, they've got information. And most of all, they have our field operations manual on call to be able to help them out in those early days. And, it really is important that they deliver the quality. And so we do spot checks. We do make sure that everything is done properly so that we can help them remedy and make sure that the customers' needs are addressed. There are also, a growing number of contractors who are totally on board with electrification, or already doing, heat pump deployments. In fact, doing majority heat pump deployments in their projects, and who are really open to this and are very knowledgeable about how to deploy heat pumps. And I guess our initial outreach to contractors has been to contractors which have that level of know-how, expertise, and of course, passion and mission that is really aligned with what we're doing. And we just work together, and we have our field ops manager whose primary job is to work with them and make sure that it works.
Great, thank you. Are you working much with engineers and architects?
So indirectly, I mean, they're part of our network, they're part of our community. They can recommend projects, put us in touch with homeowners. So it's more that informal approach. There are a couple of homes with architects that we're looking into right now. Fuzzy answer, but I'd say somewhat is the answer.
But you're not opposed to working with a client's architect or?
Oh, no, not at all.
Or an engineer. Yep.
Welcome it.
Yeah. A question about, and I think we'll close the questions after this, is curious to know if you're still heating water up to 150 degree Fahrenheit during the summer when homes only require hot water for domestic hot water, or if the pod brain adjusts water temperature seasonally. Seems like it would be wasted energy.
That is such a good question. Thank you very much, whoever asked that question. So the 150 degree Fahrenheit is a time when the Sanco 2, it's the temperature at which the Sanco 2 performs at the best efficiency. So for the overall efficiency, that is the temperature that we really focus on. But whoever asked the question was quite right, and that you certainly don't want to waste energy. And one thing that pod does very smartly is determine and anticipate how much hot water will be needed and make sure we only store it for the appropriate amount of time. So for example, in summer, it may only be heating maybe a third of the tank or less at 150 degrees, and making sure that it's topped up and it always meets the need of the homeowner. In the middle season, it might be filled up more, and in winter, it might be filled up completely. The pod understands what is going to be the need of the home for heating, and sometimes not heating, and always for hot water, and make sure you have the capacity there. So it's always thinking ahead. It's got machine learning to adapt to the needs of the household. It's taking into account the outdoor temperature, but always it's monitoring what's happening inside the tank. So let's imagine something happens and your kid's soccer team comes around for showers. That heat pump's going on, whatever time of the day. It makes sure that you never runs out. It replenishes the tank before you run out and make sure that you meet the need. But it is adapting not the temperature of the water, but the amount of water we're storing, which is de facto the same thing, but it gives us that high efficiency operation that we really want.
Thank you. In there, I heard probably a key principle of your business model. The pod knows.
The pod knows, yeah.
Yes, trust the pod. Another question about tanks. I think somebody wants to really hone in about the opportunity to use horizontal tanks.
Mhm. So stratification is important in the tank. And so it's different, more elongated form factors may cause challenges with that. And so smaller tanks side by side may be a better solution. It's something we could happily take offline and discuss with the person who has that question. We have discussed it with other people and found pretty good solutions for them. But often that compactness of the cylindrical tank is actually a good way to go because you're minimizing the surface area, you're minimizing the ports. So, but really happy to discuss, see what the specific challenge is and see how we can help work through it.
Great. Jane, would you mind putting your last slide up one more time so they have your contact information?
Of course.
We'll leave that up there for the end of it. Thank you. Thank you so much for coming and joining us today. Thank you for your really compelling presentation and bringing innovation to the electrification community. Really appreciate it. And thank all of you for joining us at BDC Presents. Join us next month for another exciting talk with other leading lights like Jane that are bringing innovation to this marketplace. And join us on all of our California and New York policy calls and other lunch and learn opportunities for members. Thank you for joining us. We'll see you out there in the decarbonization world. Keep decarbonizing, everybody, and we'll see you out there. Thanks so much. We're closing the webinar.
Thank you.